Hello all, in this video we will be learning about Unit 1 of CNC technology. So Unit 1 name is Introduction and CNC Machine Elements. So here we will be learning about need of CNC technology, applications, advantages over NC machines and machine structure. So we will be learning about machine elements. So different machine elements are machine structure, guideways, feed drives, spindles and spindle bearings. So what is CNC machine? The term CNC stands for computer numerical control. So computer numerical control. It is a subtractive process, manufacturing process. We are not doing as an additive manufacturing. We are doing as a subtractive manufacturing, which employs computerized controls. So all the some of the controls are done by computers. If you give instructions, automatically computer will control, and it will create. If you keep a raw material, and it will give the finished product and remove layers of material from a stock piece. So we have a some 10 workpiece. From that workpiece we will get the final output by subtractive method. It is known as the blank or workpiece and produce a customized design. So we keep a workpiece and we can generate the customized design by using this CNC machine. This is a process suitable for wide range of materials including metals, plastics, wood, glass, foam and composites. So these are the materials we can apply the CNC machine. And applications variety of industries like large CNC machines, machining of parts and prototypes, telecommunications and CNC machining aerospace parts, which require very tight tolerances than other industries. So coming to here, so wherever we required machining of parts prototypes, so here we will use this one because it will we can produce better tolerances than other industries. And basic CNC machine process include following stages. First, we have to design the CAD model. So you should have the CAD model. Then you have to convert the CAD file into CNC program, and then we have to prepare the CNC machine. So preparing the CNC machine itself, we have to on the CNC machine. We have to check the coolant, and we have to check all the are working or not, and we have to transfer the CNC program to the machine, and we have to change the tools. We have to keep all the tools, required tools what we have mentioned in the program, everything. Next we have to execute the machining operation. So how the machining operation, we have to start the machining operation. Okay. So these are the following stages. So these are the stages including CNC machine. Next, need for CNC machine. So first one is greater efficiency. So here we have the greater efficiency for CNC machines. So because we have automated, so everything follows a sequence, so it will run automatically, and it will increase the speed and quality will be increased and speed of the manufacturing will be increased. So if CNC machine is not used, if we are making any drilling operation, the worker has to go to take the workpiece, take the drill bit, and you have to drill manually. It takes more time compared to this one. So CNC is a very greater efficiency, and it can go without any break. So for a human, the human has to break for 1 hour, 2 hours, 3 hours for his snacks, his tea, his lunch, his nature call. So without any break, we can perform the CNC machine continuously. And machines controlled to computers does not fatigue. So they don't feel any fatigue. So when a human is working, he cannot work continuously. He may feel fatigue, but the CNC machines will not be feeling fatigue. And such efficiency can never be achieved through manual process. Manual process can never compete with the CNC machines. Next, more accuracy. So CNC machines are programmable, and each and every detailed production process can be fed into machine. By using CNC machine, identical parts can be made. So if you are manufacturing same parts and again, then CNC machine will give more accuracy and identical parts. Two parts are manufactured by CNC machine, then it will have same thing without any error because the program is same, the machine is same. Then you will get the same identical parts with highest accuracy. Accuracy is almost same for both of the cases. The programming specifications and designs of the machine leaves no room for mistakes or error. So if you are using a CNC machine, there are no mistakes or no error in the CNC machine. So therefore we get the higher accuracy. So high accuracy levels also make it hard for others to duplicate and steal the design of products. So when you're making higher accuracy products, then other person cannot make duplicate your product, because if you want to duplicate also, the accuracy of the his product will be very less compared to your product. Okay. So second is more accuracy. Coming to the third one, fabrication. Several operations are involved in fabrication, such as welding sheets of metal, shearing, punching holes, everything we can do. So, if you want to make any fabrication of any material or any operation, like welding operation, sheets, if you want to make sheets of the metal, if you want to make the shearing, cutting, punching the holes, or flame cutting process, everything you can use by CNC machine. Large machine can be fabricated to CNC according to the desired specifications. CNC machines are reprogrammable, flexible, which make them an ideal choice for fabrication. So, whatever may be the fabrication, you can reprogrammable CNC machine again and again, and you can make any fabrication or any design you can make by using the CNC machine. Next one is increase in productivity. Obviously, when you are using CNC machines, productivity will be increased, and same standard we all the standard for the products are same, and without needed for additional skilled labor resources. So without adding any skilled labors, we can increase the productivity. But in manual, if you want to increase the productivity, you have to increase the number of labors or skilled labors in order to perform the productivity. Next, saves times and money. So we can save the long working hours. So instead of working for one piece 24 hours, we can make within in 1 hour, we can make the by using CNC. So time will be saved and money will be saved instead of working. So when we are saving 23 hours of time of manufacturing, then our money is also saved in as an indirect cost and direct cost. So producing maybe custom orders in less than labor intensive manufacturing. So what are the custom orders is there, we can make or manufacture within less time than the labor intensive manufacturing. So here, next, decrease the material wastage. So CNC machines are precise. So whatever the tolerance will give, exact precise will give, and eliminate human errors. So human errors are completely eliminated. Therefore, decrease the materials are wasted. This saves your business money not only in reducing waste but also the component time spent on rework. So here we are not doing any reworks, and what are the material is wastage, it is very less wastage. If you have done any error, again we have to throw the material, again you have to manufacture. But here there will be very less reworks or any other thing will be very less. Okay. Next, it is safe to use. It is safe and easy to use. CNC machines operators do not need to get close with the cutting tools, which decrease occupational health and safety accidents. So whenever you are using on normal manual, then you will be using the coolants and all those things. But in CNC machine, what we do is, when we are manufacturing, we will close the doors and we will start manufacturing, so that there will be no there is no decrease in the occupational health and safety accident. So when we are closing the door and we are doing, whether if the tool is outside the table or anything, it doesn't touch or it doesn't have any accidents. So it is a business will be safe for staff. And next, future proofing your business. So while we introducing the CNC to a business, allow the changing in the designs, building codes and standards. So we are maintaining some standards, we are maintaining the codes, and we are keep changing the designs. So this business will keep up the changing the world of manufacturing, so that we'll be up with the latest technology. So whatever we can manufacture, we can be manufacture with this one. If you buy a manual CNC, manual lathe machine or any milling machine, then you are not future proofing your business. Next, free up the skilled labor do you have for specialist skill work. So if instead of paying huge amount to the skilled labor, we can have we can free up the skilled labor and we can have the specialist skilled worker only for one machine. Okay. So one person can handle 4 to 5 CNC machines at a time, so we can free up the skilled labors. So mitigating business risk. So software and automation implementation formally capture business process rather than leaving this open to. So there are business risk is very less if you are using CNC. So if you go for tribal knowledge, it's just one risk where selective few people in your business understand the process they have in their heads. Okay. So it is mitigating the businesses. So businesses will be very less if you are using this CNC, and you are maintaining the confidentiality of your products or business. So you can discuss only with a few members of the business, so that your business will not have any leaks to others. Next, opening the labor pool to include the lower skilled tier of employees. So, if you are using CNC, we need only one specialist machine, a machinist, and other we can take very lower skill for doing the account jobs and other things. We use very lower skilled employees we require. So that is the advantage. Instead of having the high skilled employees, we can have a lower skilled employees. Next, less time and money spent on staff training. So this is CNC machining is very easy, and you need to have staff training at very less time. Then it is the time will be less, and money spent on staff trainings will be very less. So within 1 or 2 weeks, the every staff can understand and they can implement again and again. So no need of frequently training the staff by using CNC machines. Next, advantage of CNC compared to conventional machining. So machining is accurate. So accuracy is more compared to NC, and time is very less for performing the job operation, and it is very safe to operate. Next, number of operations required to operate machines are reduced. So suppose in the manual, if you are for one machine, one person is required. For four machines, we require only one person for CNC machine, and no possibility of human error. So there are no human errors in this CNC machine, and reliable. You can reliable. Just you can switch on and you can relax. So it will make the final output ready when it ends. Even very complex designs can also made. So even complex designs also we can manufacture by using this CNC machines. Next, low maintenance required. The maintenance is very less in this case, and they are very versatile. We can use different types of machines. So it is we can use for milling, we can use for lathe, we can use for drilling. There are very versatile in this one. Next, uniformity in design. So all the designs are uniform. What are the manufactured products are there? All the products are single uniformity in design, and they could run for complete 24 hours. So without any breaks, it can run 24 by 7 without any breakage. So but we have to check the coolant, we have to check the power supply, everything we have to check. If you supply the coolant and power supply, they can run 24 hours a day without any disturbances. And next, advantage of CNC machine compared to NC. So CNC can edit toolpath. So toolpath can be edited, and spindle speeds, feed, etc. can be edited. So in the program only we can edit. But if you NC we are using a punch tape. So already the tape is punched. So we have to keep a new tape in order to edit the toolpath and other thing at the type at the site of machine tool. So CNC is more compatible with the use of computer indicated CAD and CAM facilities. So we have a system. So directly we can model the CAD model, and we can also perform the manufacturing operation softwares we can install, and we can directly manufacture this by using CNC, which is not possible in NC. And next, it is possible for users to generate specialized part programs. These programs generally take form of subroutines. So our functions stored in the CNC. So subroutines are nothing but we are creating a loop. But in NC, if you're manufacturing NC, you cannot create a loop. But if you are using CNC machine, so suppose we are making a uh, drilling from we have to make a drill of 100 mm. Example, we are making a drill of 100 mm. So what we do is directly we cannot take a 100 mm drill bit, and we directly we cannot make the drill. So first we have to go with smaller diameter, like 20 diameter, next 50 diameter, next 75 diameter, next 100. So we have to create a subroutines. So this subroutines is more feasible in CNC machines compared to the NC machines, so that we can in the memory directly we can recall the program, and we can execute frequently in the cutting sequences. Or else in one program, if you want to insert the second program directly at that point, wherever you require second program, directly you can import the second program by using subroutines. So new options like parabolic interpolation can be added to the system at low cost. But in NC, if you want to add parabolic interpolation, then it is costly. We can add, but it is very costly. But for CNC machine, if you want to add additional parabolic interpolation for manufacturing, it is very low cost. We can add compared to NC. Next, CNC can convert programs prepared in inches units to metric units. So in the computer directly we have to use the option called convert inches system to metric. So directly all the suppose the program is written in inches system, it can directly convert into metric system with just one click. Or else like in if your company is spread across the world, then one programmer has made the program in inch system, directly you can convert into metric system. But in the NC you have to type it manually and extend the tool life since optimum cutting conditions are used. So here we are using optimum cutting conditions. So that's the reason the tool life will be more. Tool life will be increased compared to the NC. A reduction in inaccuracies in manufacturing due to reduced tape reader. So here we are not using tape reader in CNC machine. So all the inaccuracies which are there in the tape reader will be removed in this case. Next disadvantage of CNC machine. So first thing is very costly. So you have to spend lakhs and crores in order to buy a CNC machine, versatile CNC machine. And then trained operators are required. So at least one operator should be highly trained or a highly skilled person you have to use in order to operate the machine. And next, in case of machine breakdown, highly skilled professional is required to solve the problem, because when you are manufacturing the CNC machine, this will be manufactured outside of the your where you are manufacturing unit. Is there? So person has to come from Bangalore or Mumbai or Delhi. They have to highly skilled person can only make any repairs available in the CNC machine. And next, reduction in manual labor can lead to unemployment. So if you are using more number of CNC machines, then it can lead to unemployment will be increased, because there is no skilled labors are very less. Okay, so manual labors are very less. We are reducing the manual labor, so unemployment will be increased in this. If you are using more of all the industries are taking CNC, then unemployment will be increased. And installation cost is very high. So buying the CNC machine is one thing, and installing cost is very high. We have to keep the coolant we have to keep. So we have to buy the air compressor, and we have to select the place correctly, and we have to so many things are involved. So we have to give the earth ring connections, all those things. So installation cost generally very high when we are taking the buying the CNC machines. Installation is very high. So methods of improving machining accuracy of NC or CNC machine. So if you feel that some inaccuracies are there, then these are the things we have to follow in order to improving the accuracy. So feedback device, we have to have a feedback device. It is mounted on the lead screw. Measure is precise position. So we have to compulsory have the feedback in order to improve the efficiency. So there are few things which apart from this one is tool deflection. When the tool got deflected, then tool edge against the workpiece in milling and turning deflect the tool and tool holder, which cause dimensional error. So if the cutting tool is slightly deflected, then we may get some dimensional errors. So this tool deflection can be minimized by increasing the stiffness of the construction of tool mounting. So wherever we are mounting the tool, we have to increase the stiffness of the cutting tool, then automatically the tool deflection will be very less. Okay. Next. Next is the chatter. So chatter is nothing but the vibratory response to the tool deflection. So whenever the tool is deflected and we are performing, then there will be some vibrations will be generated. Nothing but the chatter will be generated. So tool and material, between the cutting tool and material, the chatter is generated. This phenomenon might be occur at the tool deflection, because the tool is deflected, then automatically. So same improvement, we have to increase the stiffness and we have to eliminate the chatter which occur the same cutting condition again and again on machining with less stiffness. So we have to make sure that our stiffness is more compared to the other. And lead screw. So inaccuracy is caused by mechanical linkage between the lead screw and tool. So whenever we are moving the lead screw, the tool will be moving, and there might be some inaccuracies linking between lead screw and the cutting tool. So each axis should be mounted on the lead screw in order to improve the accuracy. This mechanism must be time invariant. Time invariant nothing but no heating effect. Without it shouldn't have any heating effects. This lead screw should have any heating effects and no backlash error. No backlash or friction or overcome the friction. So backlash is nothing but some kind of error where if you have backlash error, it is you will get more number of inaccuracies. In NC machines, routers are replaced with bearing slides. The slick slip phenomena avoided by using roller, aerostatic ball bearing or bar bearing lead screw. Okay, so because of these reasons, we can improve the accuracy of the machine. And one more is thermal deformation. The thermal deformation is nothing but the heat which is generated. So there are total three sources of heat in the machine process: spindles and driving motors, the friction sideways leads to. So these are called, in these places the heat is generated frequently more, and a non-uniform heat distribution along the machine can cause deformation. If a non-uniform heat is generated, then it causes deformation. So we have to consider the design stage. We have to include the removal of high power motors from the machine base. So if you have motors in the machine base, then the motor is also will be generating the heat. So these things should be removed, and low friction bearings and symmetrical distribution of the heat source. Okay, so these are the thermal deformation. Next, applications of CNC. CNC machining prototype productions are not tied to any single sector. We can use anywhere. So there are different number of applications we can use for CNC. It is not that we are using only for one thing. We can use for many of the things by using this CNC machine. So first one is aerospace industry. Compulsory aerospace industry need very tight tolerances because we are spending huge amount of money. So compulsory they will be using CNC machine. So provides aerospace industry with plenty of options. So this is the aerospace manufacturing of some turbine blade by using CNC. And second one is automotive industry. So all the vehicles what we are buying, so those vehicles cylinder, blocks, gearbox, valves, axle or any other component will be made by CNC machine. So this is one type of car part, vehicle part, so that it is manufactured completely in CNC machine, so that we'll have very high accuracy here. And coming to the third one, consumer electronics. So all the electronic items generally we are making like laptops. In the laptops we use for the motherboards, laptops, smartphones, many other electronic items are using this CNC machine in order to make it faster. PCBs, we are making any PC printed circuit boards or housing jigs and fixtures, etc. Other components also comes under consumer electronics. Next, defense industry. Next, defense industry is also completely reliable on the CNC machine because we have minimum wear and tear of minimum wastage. So the wear and tear is less and wastage of material is very less. So compulsory in the defense industry we using. So here they are manufacturing the bullets. So these bullets are also manufactured by using CNC machines. Next, healthcare sector. So healthcare sectors, whatever the healthcare sector, because the life is more important than the money. So healthcare sectors is also using the CNC machines for medically safe materials. Okay, like tolerances if you are making anything. So these are this spine is there. For the spine, they are giving the supports. These supports or surgical instruments or any orthopedic any implants are manufactured only by CNC because we need more accuracy than the cost. Okay. Next, oil and gas industry. So this oil and gas industry also use CNC machine for manufacturing of piston cylinders, rod pins, etc. Next, rapid prototyping. So if you use the rapid prototyping or 3D printing, so they also use this CNC machine because it is robust, and we here we'll get totally good tolerances we'll get. That's the reason we use this CNC machine. Next, production. So if you want to have any production industry, so for production industry also we use this CNC machine to generate the final parts. Next is hybrid manufacturing. So if you want to combine any two like casting, metal casting, rolling or 3D printing or any other process, if you want to combine hybrid manufacturing of two manufacturing process, welding or any other thing, we can use the CNC machines and it can perform two hybrid more than one manufacturing with ease, and we can get superior parts quality. And electrical discharge machining. For electrical discharge machining also we can use this CNC machine. It is very helpful. Next, Types of CNC machine. So there are different types of CNC machine. We have seen application. Now we have seen the types of CNC machine. So first one is milling machine. Milling machine is the largest machine we can use for CNC machine. It has generally ranges from 3 to 6 axes. So x-axis, y-axis, and z-axis. And it is relatively big and costly compared to all the machines. CNC milling machine is the largest. Okay, so this is the tool, cutting tool. These are the instructions. This is the screen, monitor screen. These are the keyboards. What we do, and these are the bytes we can do. And this is the table. And this is the we have whenever we are operating, we'll close the doors and we'll operate. And this is the z-axis. This is the z-axis depth, and this is your x-axis, and this distance is your y-axis. So all the three axes will be available in this CNC milling machine. Next is the CNC lathe machine. So compared to milling machine, this is lathe machine are very small, and we have fewer axes compared to CNC lathe machine. So this is a milling machine, and this CNC lathe machine we can keep off cylindrical objects. So whatever the cylindrical objects are there, we can place the cylindrical object. These are the cutting tools we are available. This is the coolant we are available, and we have to close this. We have to close this door, and we have to use this one. Okay. In this case, we can use like two capstan and turret lathe are the two examples we can use here. In this case, there are many operations you can perform on CNC lathe machine like facing, threading, knurling, drilling, boring, reaming, taper turning, etc. by automatic we can do. And this is a sketch we have to draw in the exam if they ask to draw. So this is a safety window, carriage, electrical cabinet, monitor, CNC keyboard. This is the tailstock. This is the headstock. This is our main spindle. Like this is the tool turret where the tools are placed. This is the cover to close, and this is our motors. The motors are below the headstock. These are the hydraulics, and this is the chuck we will be using, and this is a bed, and this is a frame what we will use for this CNC lathe machine. And next, CNC drilling machine. So the CNC drilling machine equipment are mainly used for making the holes, and it will have good tolerances and tight as 0.001 mm tolerances we have in this case. And this is the CNC drill bit. So this is a CNC machine screen. These are the keyboard. This is the start button. Green color is the start button, red color is the stop button. So when we have to move the workpiece from one place to other place, so automatically we have to move the workpiece from one place to other place. Automatically we can make the holes continuously. So it has variety of material like wood, plastic, and metal we can make. And CNC machines drilling machine has tool turret which is enable several. We can keep several drill bit tools we can enable, and we can create hubs and gear blanks and machine shafts, etc. We can manufacture by using this CNC drilling machine. Next, CNC laser cutting. So as the name suggests, we use laser light in order to make. If you want to cut any of the thing, we will cut by using this one. And this is applicable for timber, metal, and plastic. So here we use highly focused ionized gas or laser. So it has very greater precision and better surface quality compared to the others. So in this CNC laser, so we'll just cut the material, and shape is frequently in the form of CNC laser cutters, and it will move front and back. And in CNC laser machine we'll use like gases like laser like CO2. So it will heat, this laser will heat and vaporize, and this material will be vaporized, and the cutting action will be taken place in the CNC laser cut. So grinding machine. So this is our grinding machine. So on this shaft we have to make sure that it is smooth. So this is the grinding wheel. On this grinding wheel will roll continuously, and it will move front and forward and back, so that we'll get very good smooth surface finish. So it is applicable for camshafts, ball bearings, transmission shafts, etc. So we'll get exact and precise finish if we are using this one. Also, all the cylindrical objects are frequently produced with CNC grinding machine, so that we'll get more accuracy all the cylindrical objects. Next, water jet machine. So here we use as a water. So water, forced water. high pressurized water is cut through this material. So when we are passing high pressurized water, it frequently cut, like these materials we can use on plastic and aluminum, which are sensitive to temperature and might melt at high temperature. So when we are sending very high pressurized water, so it will go to heat, melting temperature, and will cut. So we can add any extra abrasive like garnet or aluminum oxide, so that we can perform very effective cutting operation. And water jet cutting machines are more expensive than plasma cutting and less softer than CNC laser cutting at the same specifications. Next, plasma cutting. So this plasma cutting has provided very high level of cutting. So here we use the plasma arc. So they only varies from laser cutting. They use plasma flame to do the cutting. So it is similar to the laser cutting. Instead of using laser, we use plasma in order to cut the operation. So very high power charged gas at 50,000 Fahrenheit are generated in the plasma torch. So it is electrical conductive, effortless, and slides to this immense heat. It will slice the material. Next, electrical discharge machining. So in this machine, we'll pass between two points. Between these 2 points, we will pass the electricity between the, this is the workpiece. So between two parts we'll pass the electricity so that we can make any cuts. So it is damage the materials which is delivered since temporal impact. So it will have, this electrical spark will have some impact, temporary impact on the material. After some time it will be normal. So electrode top and bottom regions, the computer determines how much electricity discharge, then electrodes will be created. Yeah. Okay. Next, CNC rotor machine. So in this rotor machine, so this is very fixed place, fixed table, and we can perform. This is a machine, just we can click on start, it will start. So it will have a machine base, spindle, stepper motors, stepper drivers, and stepper motor controllers, and power supply. In order to make this rotor, it will work with only softer material and very less accurate. We can use this CNC rotor machine. Next is 3D printer. So 3D printer also use CNC machine. So it will run on the course on G course and M course, so that we can generate any 3D printing object in this case. Next, types of CNC machine. So fifth one is 5-axis machine. So if you take the 5-axis, instead of having general 3 axis, it can have XY direction, and additional 2 axis will be added. XY and YZ axis will be added, so that there are total 5 axis. So generally these are used to produce sculpture. If you want to produce any sculptures, then you can use this 5-axis machine in order to generate any sculpture by just by giving the program. Next, pick and place machine. So just it will pick the object from one place and it will place it other side, and it has many nozzle, it has correction. So it will be manufacturing of cell phones, computers, and tablets, etc. We use by using this pick and place machines. Okay. Next, CNC machine elements. So first we will see the what are the parts of the CNC machine element. So first one is input devices. Next is machine control unit. Next is machine tool, driving system, feedback system, display. So there are total 6 parts, and this is a sketch of the CNC machine elements. So here from the input device, we will give all the inputs like program or anything we'll give to this machine control unit. And this machine control unit has two things. First one is data processing, and second one is control loop unit. In this data processing unit, it will process the data which we get from input, and it will check the control loop unit. It will pass through the control loop unit, and this control loop unit will control, it will show few of the things which I want to show, it will show to the display. And next, this control unit will again divide into two parts. If it has to give the instruction to machine tool, it will give instruction to machine tool. If it has to give the instruction to the driving system or motion data, it will convert into two data. One is motion data and one is miscellaneous function, and this driving system will drive the machine tool. Okay. So this machine tool will take instruction from two things. One is from control loop unit and also from the driving system, and then the machine tool will run and it will check by feedback devices. Device will check that whether if I give 50 mm movement, whether it has gone 50 mm movement or not. It will check example like position, whether it has gone x0 y0 or not, or velocity or speed. It will check the speed. From velocity we can calculate speed, so it will check the speed whether it has got the 3000 rpm or not. It will check. Next, these instructions will given to control loop, and these instructions are shown in the display unit. Okay, so this is the explanation for the machine elements. Now we'll discuss each and every part in detail. So first one is input devices. So input devices are the communication to give all the instructions. So this communication is done by via rs 232 communication. So here we will do only by using rs 232 communication is only used here in this case. So what is meant by 232 configuration is we have data terminal equipment, data communication equipment. So we'll connect from terminal to communication equipment. So first one will detect data set ready, receive data, request to transmit data, clear to send data, terminal ready and ground. Okay, so these are the different ways. So first one is data carrier detected. First we have to detect the data, then we have to receive the data. After receiving the data we have to transmit the data, then then the data terminal will be ready. So that we can get the accurate driving. Next, auxiliary control functions such as coolant and spindle on and off, everything will be. So here we'll be sending like coolant on, spindle on and off, tool change, etc. We give miscellaneous functions from the control loop. So this is the MCU. So complete MCU is there in this one. So this is the CRT display, key buttons, everything is there, and this is the sketch of MCU. Next, next is the machine tool. So this machine tool is nothing but the cutting tool, or it consists of sliding table and spindle of the control to control the position and speed. So for each and every time, so this is my x-axis. For x-axis you have one drive, for y-axis you have one drive, and for z-axis you have one more drive in order to have the control of the spindles. Next, driving system. So this driving systems will amplify the circuit's driving motion. So we have a PC based controller. So this will give commands so that they have a ball screws here. These are the ball screws. You can see these are the ball screws. So these ball screws will move this tool table from one place to other place, and you have bed, you have table, motor of y-axis. So this motor of y-axis will give instructions to move in horizontal, and this lead ball screw will move in this direction. So this is the motor of x-axis. This is my optical scale. So driving system has to take care all of these instructions. Next is feedback system. So this system consists of transducer act as a sensors. Okay. So here you have a table. So this feedback system, a drive motor. Suppose the drive motor have you given that x-axis has to move 50 mm. The feedback has taken that x-axis has moved 49.99 mm. So it will give the feedback that 0.01 mm is have some error. So this MCU will again give instructions to the motor so that the feedback is adjusted. This will be completed within a fraction of seconds. So whatever the MCU receives the signals, it will transmit to this transmitter, and the difference of the reference signal is feedback will be generated, and it will correct the position. So it will correct the position and it will reduce the speed error. Suppose I give 3000 rpm but is rotating only 2998 rpm, then whatever the errors are there, it will compensate those errors. Next, for the feedback system, this is a sketch of the feedback system. So you have written a CNC program. This CNC program will go to MCU and CNC MCU. This CNC MCU will have access amplifiers. Okay, this access amplifier will voltage or current control. It will send voltage to this drive motor, and here we have tachometer to measure the speed or velocity. So this tachometer, so this tachometer will be giving the velocity feedback, okay, to this access amplifier, so that it will again rectify and it will again send. Okay, then this drive motor will give ball and nut. So there is a movement in the ball and nut table. So we have ball screws. So again it will be measured by resolver or encoder. This will be measured by resolver or encoder, and this will be given feedback again. Okay, so again this whatever the speed here is, again it will come back to this portion. Okay, next, what are the feedback axis feedback is there, it will again go to CNC. Again CNC, if there is an errors are there, again it will go to access amplifier. Again access amplifier will give this movement to this drive motor, so that this is actual feedback system generated for the CNC machine. And next, last one is a display unit. So this is the display unit, whatever we are seeing, this is the display unit. So here we can see the x-axis, what is the x-axis value, y-axis value, z-axis values, and we can see any parameter settings we have done or not. We can see the codes G00, G67, G17, G54, G90, G64, G20, and here we have, here only we, if it's a touch system, we can directly click and we can make sure. So this is a phonic series of the display unit. Next, working principle of CNC machine. So first we have to create a part program. This part program is inserted into the MCU, machine control unit of CNC. Then MCU will read the data and it will prepare all the motion commands and will send to the driving system. Next, this drive system works as a motion command and sent by MCU. This drive system control the motion and velocity. So it will control the what is position or motion and velocities or speed of the machine tool. Next, we have a feedback system. This feedback system record and transfer the signals back to MCU. And MCU original signals are compared to the feedback signals. And if there is any errors are there, that has to be compensated or corrected. Next, display unit. We can see all the commands, programs, other all the data we can see on the display unit. Next, machine structure. So machine structure is nothing but it is used for carrying load carrying capacity and supporting any of the members for this CNC machine. So all motors, drive mechanism and any their functional assemblies are aligned each other rigidly fixed to the machine structure. Machine structure is subjected to static and dynamic forces. So what are we calling the machine structures are have the static loads and dynamic loads or forces. It should not deform or vibrate. So even though we have static forces and dynamic forces, it should not deform or vibrate behind the permissible limits of that structure. Next, all components of machine must remain in correct relative positions, maintain geometrical accuracy. We have to maintain geometrical accuracy regardless of the magnitude direction of these forces. And machine structure configuration also included by considering of what you have manufactured, and assembly and operation is also matters when for the machine structure. So we have to make sure that it should have static and dynamic forces in limits, and which type of manufacturing you have done, and which type of assembly you have done, and which type of operation you have done, that is also matter. So CNC machine structure should resist these loads. So first one is the static load. So what is meant by static load? In this load, there is a load of bridges, tools, lights, columns, etc. So these structures should have adequate stiffness. So we have to have minimum stiffness in order to reduce this static loading condition. So these bridges, tools, lights, these are common load with the static load. Next, dynamic loads. So dynamic loads are caused as vibration. So this vibration is caused by unbalance of rotating parts. When any part is rotating and it is not rotating with balanced, from the center it is not rotating, then we have unbalanced rotating part. Those things will generate vibration. And improper meshing of gates. If two gates are in contact with each other, it should have the proper meshing of the gates. If that is not there, then vibrations will be generated. And bearing irregular. In the bearings, if the ball bearings are not have irregular, then not constant areas, then we'll have these vibrations. Next, when we have interrupted cuts while machining, when we are started the machining operation and suddenly there is a power cut, then we are stopping and starting again and again, then it takes so much of time to overcome the friction and it has to work, so vibrations will be generated. Next, these vibration can be reduced by increasing the mass of the structure. So if we increase the weight of the structure, then vibration it will absorb the extra vibration. Next, we have to increase the stiffness of the structure should be increased. Okay, so uh, next we have to improve the damping properties. So damping properties improve, vibration is damped or absorbed by the material. Next, thermal load. So after vibration, we have to overcome the thermal load. So there are some heat sources which will set up the thermal gradient or which will increase the thermal loading. So first one is electrical motor. So when the motor is running continuously for 24 by 7, then heat is generated for that motor and it will dissipate it. That electrical motor heat will be dissipated to the other parts. Next, friction in the mechanical drives and gearbox. So this gearbox and mechanical drives, friction is generated, so the heat is generated. Next, friction in bearings and guideways. So when the bearings are rolling or any guideways are sliding, then the friction is generated, so that automatically heat is generated. Next, machining process. When the cutting tool is touching the workpiece, then heat is generated during the machining process. And temperature of surrounding objects. Suppose the surrounding objects temperatures are heated. Suppose we are making the CNC machine beside the casting or any furnace. So outside temperatures will also affect the heat. Next, so we have to take some steps in order to reduce the heat. First one is external mounting of drives or motors or gearbox. These motors or gearbox shouldn't be there inside or near the table. It should be outside. You have to mount them outside of the drives. Next, remove frictional heat from bearings, guideways, and proper lubrication. So we have to make sure that there are proper lubrication between the gates and guideways. The bearings will roll and guideways will slide. So we have to make sure that it should have the proper lubricating system. Next, efficient cooling and swarf removal system for the dissipation of heat generated from the machine process. So swarf is nothing but what are the small pieces are generated while making the while having the chipping process. So it will also have some heat particle. Heat is generated in the swarf. So this should be reduced. Next, thermosymmetrical design. So we have to make, when we are manufacturing CNC table or CNC machine, we have to make sure that the table, the it should be thermosymmetrical. It should be dissipate the heat in all the four directions, not at only one direction. Next, reduce ambient temperature by installing air conditioning unit. So whenever we are using a CNC machine and we are running 24 by 7, compulsorily we have to install AC, so that the thermal load is reduced, because the surrounding temperatures are reduced, then automatically the heat generated will also be reduced. The friction is overcome easily. All those things will be there. Next is guideways. So a guideways is one of the most important element in the CNC machine. So it moves along the predetermined path to observe all the static and dynamic forces. So what are the forces are there? It will move in predetermined path and it will observe these forces. Next, purpose of guideways or slideways is to accommodate the axial movement of the machine slides, work table and spindle. So it will take the axial movement of the machine and work table and spindle. It should accommodate the axial movement and it should accommodate the work table. It should accommodate the spindle on the guideways. So guideways should be have the geometrical alignment. The geometrical alignment in other one, it should have parallelism to the, it should be parallel to other parts. Few will be parallel and few will be perpendicular and few has to be roll pitch and yaw. This you'll be learning in dynamics of machinery. What is meant by roll, what is meant by pitch and what is meant by yaw um, in the dynamics of machinery first unit. You'll be learning rolling, pitch and yaw. So we have to make sure that all these are provided in the this guideways. So the surface must be supported statically and dynamically by using this one. Okay. Next, factors considered while designing the guideways. First one is rigidity. It should have more rigid element. Next, damping capabilities. It should damp all the vibrations. Geometrical and kinematic accuracy. The accuracy, geometry should be perfect, and kinematic accuracy. So it has to be perfectly linked with each other, without any deviations. Next, velocity of slide. So we have to maintain. We have to consider the velocity. How much speed, maximum speed we can give for this sliding velocity. Next, friction characteristics. We have to check whether the what are the characteristics of friction, whether it is rolling friction, static friction. We have to know the characteristics of the friction. Next, wear resistant. It should be resistance to wear. It shouldn't be have wearing and tearing of parts. Next, provision for adjustment of plane. So if we don't want to have any slides, then we can stop it with the stopper. We should have that provision. Next, position in relation to work area. So within the work area only it should have the position. Next, production again the swarf. So what are the chips are falling on the guideways? It should have protection. It should have some protective layer so that the chips are not falling and the temperature is not increasing. Next, protective guards to safeguard the guideways against accidental damage. So we have to make sure that these suppose the guideways, at the end of the guideways you should have a stopper so that if I'm moving the guideways fastly, then the guideway shouldn't be fallen down from the CNC machine. Okay, so we should have safeguards or protective guards for this to prevent the accidental damage. Next, see types of CNC guideways. First one is the friction guideways, and second one is the anti-friction linear motion guideways or LM, anti-friction LM guideways, and third one is the frictionless guideways. So friction guideways, frictionless guideways, anti-friction linear motion guideways are the three types of the guideways. And friction guideways is again given to V guideways, flat and dovetail guideways, and then cylindrical guideways. And anti-friction linear motion LM guideways are linear bearing with balls, linear bearing with rollers. And frictionless guideways are again divided into hydrostatic guideways and aerostatic guideways. Next, friction guideways. Friction guideways are most widely used because of their low manufacturing cost and good damping properties. These guideways operate under conditions of sliding friction and do not have a constant coefficient. So if you see here, so this is the coefficient of friction, this is the velocity of slide. So till the slick slip range, it is followed and gradually it will increase. Okay, and it will rapidly falls and beyond a certain velocity, it will remain almost constant. Okay. Next, so friction. This is a method what we use. So types are V type and inverted V type. So we'll place a we'll keep a coating, and this coating will touch so that we'll have with respect to friction, these two will move have the movement in the guideway. So first one is the V guideways. So it is a closing action. Upper member will settle on the lower member, and this is in the shape of V, and the angles of V are different. So for different guideways, we have different V angles, and here we will have the parallel alignment of the guideways with the spindle axis. Okay, so this is the first type V guideways. Second one is flat and dowel guideways. If you see the flat guideway, so this is a flat guideway, move in the flat, and we have a jib strip in order to adjustment screw, so that it should have some safety images. And coming to dowel, dowel is in the shape of dowel. So this is the dowel shape, and this is completely flat. And here also we can place the jib strip. So here it has better bearing load bearing capabilities other than guideways. So jips are used to ensure accurate fitting of these slides, both flat and dowel. So both are adjusted by the jib strip. Like cylindrical guideways. So coming to cylindrical guideways, this is the shape. So this is the cylindrical object, and we'll make the cylindrical guideways like this, and it will support all the cylindrical like bore in the carriage. Everything loads on the light and load, transfers loads and light loads on the cylindrical guideways efficiently. Main limitation of this one is it cannot go for longer travels, because we know that if a circular object is cylinder is very large, then we'll have some deviation from the center. So it may have slag or bend in the center of the span of the load. So that's the reason we don't use this one. Okay. So for this one also we take a cylinder and we can keep a screws in order to hold the guideways. So those are friction. Now we are going for anti-friction. So we are using the rolling element between the moving and stationary element, so that the anti-friction, the friction is reduced to overcome the friction. And first one is linear bearing with balls. So if you see the sketch of linear bearings with the ball, so here we have a object and here we have a ball bearings, and these are the balls we have. This is the shaft we have, this is the balls we have, and this is the cage. So shaft is rolled in the cage, and this ball bearings will roll continuously over the shaft, so that there will be have a precise movement of the stroke length will be available by using this linear bearing with balls. Next, a linear bearing with rollers. So if you see the sketch, so these are rolling continuously in this fashion between the guideways. Okay, so this is a grinding element, and it will prevent the rollers falling out. So you have this this closing case, so that the rollers will not be falling out, and we will ensure that there is a smooth return of the rollers, and the load will be zero. Load carrying will be zero, and it is friction is overcome by using these rollers. So if you use rollers, the friction is very less compared to the flat dovetail or V shape. The friction is very less. And next is frictionless guideways. So first one is hydrostatic guideways. If you see the sketch, we'll pass the pressurized oil. We'll pass the pressurized oil, and this pressurized oil will be moving between the two mating parts. So we'll give a very high pressurized oil, and this is the slide which will move in this direction, and these are the slide ways move. So high pressurized oil will ensure the smooth lubrication, so that friction is very less, or will or very minimum or very no friction. So pressure is high as a 300 bar oil pressure will pass. So we have hydraulic machines, so that we'll convert this pressurized oil here. And friction wear and stick slip are entirely eliminated. So friction wear is eliminated, and stick slip is nothing but one material is sticking to other material, that will be eliminated by introducing the pressurized oil. And the dynamic will be stiffness will be increased, damping properties will be improved by the if you use pressurized oil. And but the main disadvantage is it is very high cost. The cost is very high and very much difficulty in assembly, because we should have very tight tolerances, and only we have to keep a passage only for passing the oil. Okay. So for assembly also it takes more time. So this is friction. And next is aerostatic. So as the name suggests, we use pressurized air in this one. So this pressurized air, we pass the same procedure, just we pass the pressurized air, but it is very cost is less. Only thing is cost is less, and generally we use for positioning. If you want to know the position of the guideways, then we use this one. Generally we use for coordinate measuring machine, we use this aerostatic guideways to know the just for position only, because the coordinate measuring machine will measure the coordinates of the workpiece whatever we are keeping. Okay. So this is about the guideways. Next, CNC drive system. The drive system is an important component of CNC machine as accuracy and repeatability depend on the characteristics of the the drive. So here we have two types. One is spindle drive, next one is feed drive. So these driving systems are two types. One is spindle drive and feed drive. So every CNC machine should have this driving system to have the accuracy and repeatability of these driving system. Okay. So two types of drives, spindle drives and feed drives. Next, coming to the spindle drive. So this is a spindle motor. So this spindle motor will give the power to this shaft, and it will have this spindle here. So this spindle will rotate the workpiece. Okay. So these are used to provide angular motion to the workpiece. So for the it will hold the workpiece so that the workpiece will roll. For this lathe machine, CNC lathe machine, the workpiece has to roll. So same thing, and the speed ranges can be from 10 to 20,000 RPM. It will range in that range. So these are spindle drives, and nowadays we use AC spindle drives are preferred to DC spindle. Nowadays we are not using DC spindle, we are using only AC drive because of microprocessor AC frequency inverter. We use only AC drive, so that high load capacity spindle drive is required. Therefore we use, if we'll get very smooth operations if we use this spindle drive with AC. And coming to the spindle drives requirement, one is compactness. Another one, it should have very small, and power ratio should be high. Weight to power ratio should be high, and high loading overloading capacity. If it is maintained, for example like 50 kgs, it can hold up to 70 kgs or 75 kgs. So it should be having high overload capacity, large speed range, at least 1 is to 1000 range it should be able to generate by using spindle speed, and high rotation accuracy. If I give 300 rpm, it has to rotate 300 rpm, high rotation accuracy. And maximum speed can be 9000 to 20000 rpm, and range of output should be 3.7 kilowatts to 50 kilowatts. Next, wide constant power band. So this power band should be constant. It shouldn't vary from one vary the values. Next, fast and dynamic response. It should have very fast and dynamic response. If we are given the rotation command, it should have rotate within the half of the second. And excellent running smoothness. So smoothness should be there. It shouldn't deviate from its center. Next, feed drives. Coming to feed drives, it consists of electromotor and mechanical transmission elements. Feed drive should have constant torque, positioning, and to drive the slide or table. So this is the CNC feed drive. So you have the feed motor, and you have ball screw mechanism. This on this ball screw, you have a table, and here you have a ball screw nut. So between the two, it will feed from this place to this place. It will move continuously. The work table will move continuously. So this feed drive will take care of the work table, and the spindle drive will take care of the workpiece, movement of the workpiece. Next is the requirement for CNC feed drive. So we should have high torque to weight ratio, and low armature or rotor inertia. Next, low electrical and mechanical time constraints, permanent magnetic construction, maximum speed up to 300 rpm, high peak torque for quick response. The required constant torque for overcoming friction and working force must be provided. So here the torque should be more to weight ratio. The weight should be less and torque should be more, generating more. And armature rotor inertia should be very less. When we are rotating, inertia should be very less, and electrical and mechanical time constant should be very less. And permanent magnetic construction. So magnetic construction should be permanent. The permanent magnet should be placed for the feed drives, and maximum speed up to 300 rpm. So the table movement should be 300 rpm, and high peak torque for quick response. So we have to give the very maximum speed. We have to give the torque for we have to give high peak torque for quick response. The required constant torque for overcoming frictional and working force must be provided for this CNC drive. Next, spindle. Coming to CNC spindle, spindles are electrically or air powered. So if you see the spindle, so this is our spindle. So This spindle should be electrically powered or air powered devices that in numerous come in numerous sizes. So different sizes spindles will be coming. There's a shaft that holds the tool together. Motor tape used to control various tools. The spindle rotates on an axis. So this axis we call it as x-axis or y-axis or z-axis. One axis will be there. So it will control by commands either from a person or a computer. Okay. So CNC spindles are crucial role in machining. These components are fundamental, fast, and efficient process, while also ensuring that produced elements are precise as possible. So we have to make sure that it should be as precise as possible, and it is very important part. Spindle is a very important part. The machining center, the form of the spindle determine the speed. How the shape of the spindle is there, it will determine the what is the speed and cutting force of the machine. Next, this is the spindle diagram. So this is the what spindle diagram we have to draw in the exam. So here this is the tool, this is the cutting tool, and this is the tool holder. This tool holder is inserted in this spindle, and here you have housing, and this is the shaft we have, and this is the hydraulic fluids what we are moving, and these are the ball bearings having for smooth rotation, and you have a pulley and clamping unit here. Yeah, this is the nut so that it shouldn't fall out of it. Next, we have spindle nose. So this is spindle nose, and it is inserted in the spindle. Okay. So this is about the spindle. And next, characteristics of a spindle on a machining center. So spindle is a high performance element. It should have a very high performance. Spindle works with high torque, high power, and low speed. So the torque should be high, and it should have very low speed at milling operation. It works with low torque, low power, and high speed when required to drill any small diameter holes. So when for milling operation, it should have high torque and low speed, and for drilling purpose, it should have low torque and high speed. And spindle usually made up of high strength steel in order to make mounted on thrust bearings, radials, and extreme precision. Spindle is an extremely important in order to change the automatically tool. So if you want to change automatically tool, spindle is extremely important. The electro spindles are also extremely widespread. So in for these spindles, we can use electro spindles with an electric motor that replaces the transmission gears. And types of spindles, first one is belt drive spindle. So in this belt drive spindle, it is easy with the belt, and noise level is also very less. It can rotate up to 1500 rpm and allowed to deliver more power and torque, and it is not expensive, so it is very less costly, and we can use as an internal motor spindle. Next is gear driven spindle. It is costlier, it is high cost, and it is noisier because of gear will feel some noise will and maintenance and require more maintenance than the belt drive, time when belt driven may have been preferred, but belt driven advances materials belt design have proven to be low maintenance. So initially we use belt drives, but belt are broken or sagging, so we are shifted to gear driven. But nowadays again we are going back to belt driven because the belt material is very latest advances. There's a very good belt material, so that for low maintenance also we use the belt driven, and manufacturing of the gear is very uh, costlier. And next is inline spindles. These inline spindles are designed to spindle coupled directly to the motor. Inline spindles provide excellent surface finish, smoother, and quiet operation. Next is built-in motor spindle. So motors are built inside the spindles, and when high spindle speeds are excess 16,000 rpm are required, then we use this built-in motor. So inside the only there is a motor will be generated. So for a high speed is generated very easily. Next, integral motor. So in this integral motor, it can reach up to 60,000 rpm. So if you want very high speed, then we use this 60,000 rpm, and it can spin very quickly, so that it we use in variety of applications this spindle. And coming to the benefits, first one is accuracy. The accuracy is highly compared to the spindle. Next, versatility. It should be working at any temperature, and it can withstand any temperature, very high temperature, low temperature. Durability, it should have very less wear and tear without breaking down quickly. Next, cost effective, the high speed spindles, if you use high speed spindle, it will help you to save the money. Next, low maintenance, if you are taking care of the spindles, then they are not at all costly to maintain these spindles. Next is spindle bearings. Spindle bearings are high precision bearings that are designed for use in machine tool. So this is a spindle bearing. So these are the spaces. This is the front bearing stacks, and here you have roller bearings. In the roller bearings, you have spacer and lock nut to lock this one. And there are some holes. In order for lubrication, we are placing some holes. So these are in between. We are placing the roller bearing and angular contact bearings, and you have some spacer sets. So between the angular contact bearings, we have some. We are providing some spacer sets in order to separate them. So in this one, this is your diagram what you are drawing exam. This is your actual. So these are the spacers, rollers, angular contact, hydraulic nut, lock nut, and rail roller. Okay. So you have different types of spindle bearing depend upon type of load, whether it is axial, radial, or combination of axial load and radial load. Next, load intensity, how much load we are intensing, and how much is the rotational speed. Next, what is the spindle stiffness and what is the thermal stability. So we have to select the spindle bearing on these five times. Next, spindle bearings. So types are, first one is hydrostatic bearing. If you see the hydrostatic bearing diagram, this is our spindle, and we are inserting high pressure oil inside, and we have oil exhaust. So we are oil inlet, and from oil exhaust is from this point. So we are inserting the oil from all the four parts, four inlets and four outlets. Okay. So these are hydrostatic bearing. The spindle is supported by relative thick film of oil will be poured inside bearing through the throttling system, and in this case it is independent, completely independent, and rotational speed. It is used in grinding and boring machines. We use this kind of spindle, and it should have following merits. Advantages: high wear resistance if you use hydrostatic bearing, and high damping properties. It will damp the vibrations. Next, high running accuracy. It is highly accurate. Next, hydrodynamic bearings. In hydrodynamic bearings, the pressure of oil within the bearings is created by rotation of spindle. So if you see the bearing, so oil inlet, there are four oil inlets, and there are four oil outlets, and there are four oil outlets, and here we are providing wedge shaped cavities. So whenever the spindle is rotating, so spindle is carried to the wedge shape cavities between spindle, and there's a small clearance we are providing for the bearings and the spindle, so that oil pressure is increased. So this type of bearing is having a constant flow of oil. So here we have constant flow of oil here, and the main limitation of this type is the clearance between provided for oil film to maintain between the bearings. So we have to maintain the clear oil. So we have to maintain the clear oil film. Oil film has to be maintained clearly. Okay. These bearings are used where the load carrying capacities are low. Frequently starting and stopping of the spindle is not required for this type of machine. Okay. Next type is anti-friction bearing. These are suitable for very high speeds load or often preferred as hydrodynamic bearings. So this is the anti-friction bearings what we have. Next, we use this anti-friction bearing because of very high. We can reliable directly on this anti-friction, and very easy to replace. Whenever the bearings is wear and tear, then we can replace easily. It has very low friction and lesser ability to suffer wear and incorrect adjustment. So there's no need of having any incorrect adjustment that we can place and can use. The ball and roller bearings are called anti-friction bearings because of the contact of support of rolling elements of point contact in case of ball bearings, and line contact. So here we are in the rolling we use as a point contact, but in roller bearing we are using as a line contact. Okay. So this is the explanation.